What's going on, 7th grade? Hope everybody's having a great week, had a good weekend. Very glad that you're not seeing me right now because Mr. Gary got the haircut really bad due to the shutdown. Looking a little shaggy right now. Let's go ahead and let's get started with today's lesson. So we've got Chapter 1, Lesson 7. We've got the distributive property. Haven't heard from many of you guys, so I really hope you're understanding the material. Really hope you're watching the videos and you get your notes down. I know that's the most exciting thing in the world, but it is school. School's almost out. But like I said, if you have any questions, email me, email myself, or leave a comment on our Google Classroom page. Now let's get started with the distributive property. So the distributive property, not to sound too much like a nerd, but it is my favorite property of all math properties. And that's just because I think it's the easiest to understand. And what that means is, anytime I have something in parentheses, we always call this a quantity. Anytime I have something outside the parentheses, I'm just simply multiplying that term by everything inside. So I'm doing A times B. I'm also doing A times C. And I'm going to keep that addition symbol still in between the two. So this problem would come out to look like A times B plus A times C. So really, guys, the key component here is whatever's outside of the parentheses, you just need to make sure you're multiplying it by everything inside the parentheses. Notice I multiplied A by B and also by C, and both those are inside my parentheses. Let's get started with an actual problem here. So number 1, I've got 3. We would read this guy as 3 times the quantity x plus 8. To kind of show how this would look, it would mean I'm doing 3 times x and also 3 times 8. So 3 times x is 3x. 3 times 8 is 24. And guys, that's going to be my final answer. That's going to be kind of the one thing that I hope doesn't distract you or doesn't get you too off topic here. We're not necessarily solving for one final answer. We're going to be given an expression. So my final answer here is 3x plus 24. And that's really because I don't know what this x is. So I'm going to leave it as an x. So there you go. There's your final answer for number 1. Not too bad. Now, number 2, I did put this one in here for a reason. 90% of the time, you're not going to see a problem like this, though. I've got 5b minus 4 times negative 7. Now, normally, guys, this negative 7 is in front. Whatever you're distributing inside is normally out front. So don't be confused by these, and maybe it looks a little different. But really, it's the same thing. I'm just taking negative 7, and I'm distributing it into everything inside. So really kind of your rule here is you're taking that one thing that's by itself, and you're going to multiply that by the entire parentheses, the entire second set. Okay? So let's go through and let's distribute here. So if I take negative 7 times 5b, well, I can multiply these two together. When I multiply, I'm going to get negative 35. Don't forget about your variables. Negative 35b. Next, I'm going to take negative 7 times negative 4. That's going to give me positive 20. So my final answer, negative 35b plus 28. Let's look at number 3. I've got 5 times the quantity x plus 7. Again, distribute. If you don't want to draw these lines every time, you don't have to. It's just kind of a way of reminding yourself to multiply by everything in the parentheses. So if I do distribute here, 5 times x, 5x, 5 times positive 7, and positive 35. And there you go. There's that one as well. All right, last distributive property problem. Number 4. I've got negative y times the quantity 2y minus 1. On this one, guys, no whole number out front. This time we've got a variable. You can still distribute it. I'm still taking this negative y, into everything. So if I do negative y times 2y, my number up front's going to stay the same because I'm not multiplying by another number. I'm this time multiplying by a variable. And it's going to be negative because I have a negative times a positive. And a negative times a positive is a negative. So I'm going to start with negative 2. And then that y times y, that's going to create y squared. And then to finish it off, I've got negative y times negative 1. Negative times a negative makes a positive. Y times 1 is y. So my final answer on number 4 is going to be negative 2y squared plus y. Don't forget about that squared. A variable times another variable, let me rephrase that. A variable times the same variable is going to make that variable squared. All right, let's go ahead and let's move ahead now, guys, into numbers 5 and 6. These two are very similar as well. I'm not really spending a whole lot of time on the layout of 5 and 6, and that's because there's kind of a shortcut with these that I'm going to show you. So for number 5, I've got 7x plus 2 in the numerator. This is a fraction over 5. What this means is, okay, what am I really multiplying this whole thing by? I want to look at what my denominator is. My denominator here is 5. So I can rewrite this entire equation to be 1/5. And when we rewrite this, the numerator is always a 1. The denominator is always going to be whatever the denominator is in your original problem. So it's going to be 1/5 times, and then it's going to times that numerator, 7x plus 2. And then there you go. You can use the distributive property to solve this problem. So I take the 1/5 and I distribute it into everything in parentheses. So 1/5 times 7 is going to be 7 fifths. Don't forget about your variable, 7 fifths x. And then it's going to be 1/5 times 2, so plus 2 fifths. Here is your final answer, 7/5 x plus 2/5. Now, here's my shortcut, because you don't necessarily need this to work on these types of problems when you see them. Guys, anytime you're dividing something, that denominator applies to the entire numerator. So, the way I actually see it is, okay, 7x is being divided by 5, 2 is being divided by 5, and I need to keep that sign in the middle the same. And now look at my left side and also look at my right side. I got the exact same expression on both sides. And the only thing I did was I just made sure that my denominator applied to everything in the numerator. So I made sure that 7x was being divided by 5, and I also made sure 2 was being divided by 5. And I got the exact same expression whenever I solved using the distributive property. So there's a couple ways you can do these ones that are split up into really kind of into fractions like we see here. Let's take a look at number 6. And again, I'm going to try to do this more of a simplified way, where, okay, if I split this up, 6 is applied to the entire numerator. Everything in the numerator is being divided by that 6. So if I rewrite this, I'm going to have 4 divided by 6 minus 2 divided by 6. Don't forget about the variable. 2x divided by 6. The sign is always going to stay the same. The only reason the sign wouldn't stay the same is if there's a negative in the denominator. And you guys are not going to have anything like that, or should not have anything like that just yet. With this problem, last step, just go through and simplify. So 4/6, I know that I can simplify down into 2/3 minus 2/6. That simplifies into 1/3. And don't forget about your x. There you have it. 2/3 minus 1/3 x. All right, let's move ahead now into another form of distributive property. You're going to find, guys, in this lesson, there's a lot lot of different forms of the distributive property that we're going to see. Number 7 and 8 are very similar as well. So in number 7, I've got negative times the quantity 2y minus 3x. And don't make these problems harder than they really are, because these are really easy. Anytime you have the negative out front, it's like multiplying it by negative 1. And I can put a negative 1 out there if that helps. So then I just go through and I distribute just like I normally would. So, negative 1 times 2y, that's going to be negative 2y. Negative 1 times negative 3x, that's going to make positive 3x. And then you have your answer with that one, because an x and a y, those two are different. One's an apple, one's an orange. I can't combine them. Let's look at number 8. So again, I've got this negative out front, so it's negative times the quantity a plus 5. Same thing, I'm still making this into negative 1. You don't have to add the negative, or excuse me, you don't have to add the 1, but if it helps to visually see you're distributing a negative 1 into this, go ahead and put it there. Negative 1 times a, negative a, negative 1 times 5, minus 5. There you go. Negative a minus 5. All right, we're almost finished. We've got about 3 more problems left, okay? So, number 9, I've got a story problem. Haven't done many of these in a while. So, let's go ahead and let's get this one down without any griping or complaining. So, number 9 here, I've got Mr. Garrett is buying cookies. He needs 8 of them. One cookie is $4.95. What is the total? These are some expensive cookies, and they were hopefully are pretty good, considering one cookie is $4.95. Now, every single one of you in this class, I asked you to tell me what the total is. You should be able to tell me that I'm going to do 8 times 4.95. You should be able to tell me that 8 times 4.95. That's because one cookie costs $4.95, and I'm buying 8 of them. You guys are bright young 7th graders. You should know this part. Now, there's not really any distributing here, but the purpose of this little section is using the distributive property with mental math. Most of us, probably all of us in class, cannot multiply these two numbers in our head. But we can use the distributive property to make it a little easier on ourselves. Well, what is 495 close to? 495 is very, very, very close to 5. So I can do 5 minus 0.05. And if I subtract 5 minus 0.05, I'm going to get that 495. So these two expressions are the same. The only difference is, for this top one, you're probably going to either need a calculator or you're going to need to write the whole thing out. Whereas if you use the bottom expression, you can probably do all this in your head, and you also don't need a calculator, and you're also using the distributive property, which is all this lesson focused on. So let's go ahead and use the distributive property to solve. So I know that 8 times 5 is equal to 40. Positive times a negative, so I'm still going to keep that minus sign in the middle. Now let's do 8 times 0.05. Excuse me. I know that 8 times 5 is 40. That decimal to 5. Well, there you go, 0.4. All that done without using the calculator, and I'm probably solving this a lot quicker than any of you could if you did it like this. So again, this is just a faster way of solving problems. I do 40 minus 40 cents. That's going to give me $39.60. So there you go. It's going to cost me $39.60 for my cookies. These are some expensive cookies. All right, let's go ahead and let's move ahead and let's get into our last section of these notes. So the first thing I want to go over, not necessarily problems, but more vocab words. So I've got 3 vocab words. The first one is a term. A term is a number or variable, or a combination of numbers and variables. Terms are separated by addition and subtraction. Anywhere that we see an addition symbol or a subtraction symbol, that's 2 terms that are being separated. We also have the word constant. A constant is a term that does not have a variable. And finally, we have coefficient. And the simplest way to know what a coefficient is, it's the number that's in front of the variable. So I went ahead and I kind of wrote a simple one down. We have 3x plus 2. If I want to look at my terms, remember, terms are separated by addition and subtraction. So here's my addition symbol. So my term is 3x and 2. So there are 2 terms in this problem. My constant, that is a term with no variable. Well, my first term has x in it. Guys, that term, you have to put x. If you just put this as 3, that's wrong. So constants have no variable. The only term without a variable is 2. And then last but not least, I have my coefficient. And that is the number that's in front of a variable. Variables are always going to be your letters. 3 is in front of x. So 3 is going to be my coefficient. Now, I made kind of a more complicated one on the right. We have 6a squared minus 5ab plus 3b minus 12. Let's go through this one. So terms. Again, terms are separated by addition and subtraction. So my first term would be 6a squared. I want that whole thing. My second term is going to be 5ab. My next term is going to be 3b. And my final term is going to be 12. There are 4 terms on this problem. Next, my constant. This is my term with no variables. So which of my terms does not have a variable? It's going to be 12. So 12 is my constant. Next, I want my coefficients. And these are the numbers that are in front of variables. So notice, 6 is in front of a squared. So that's one coefficient. I also have 5 in front of AB. Now, 5 is a negative symbol in it, so it's going to be negative 5. And then my final one is going to be 3, because 3 is in front of B. So again, on this problem, we've got 4 terms. You've got one constant. Now, one constant is going to be 12. And then you also have those 3 different coefficients. It's important that you have negative 5 in front of that first coefficient. All right, let's go ahead, and the reason I'm talking about this, guys, is because of our very last section in this note. And that last section has to do with combining like terms. I'm going to write that down, because that's what we're doing here. We are combining things that are similar. Combining like terms. You're going to see that over and over for the rest of your math life. All right, so number 10. you've got 8x squared plus 2x. These are terms. Then you want to look at, okay, is the variable the same? My first variable is x squared. My second variable is x squared. So I can combine those two. So when I combine them, that's going to be 8 plus 2, 10x squared. And that's it. And we're just going to leave it like it is. Number 11. Negative 7mn to the fourth minus 5mn to the fourth. Again, two terms. They're separated by the subtraction symbol. Both of them have mn to the fourth. So I can combine these two. So negative 7 minus 5. Last problem, and then we'll be finished with notes for the day. Number 12. I've got 8x squared minus 2x to the fourth minus 2x plus 2 plus xy. And this was a very long wrote out problem. This is one that's driving me absolutely insane because I got it straight from the book and it's not in order. Should go with your highest exponent first. The number 2 should be last. That's a discussion for another day. However, can I combine like terms here? The answer is no. This problem is simplified as far down as it can go. And the reason is, I've got 1, 2, 3, 4, 5 different terms here. If I look at my first term is x squared. There's no other x squared in this problem to combine it with. My next term is x to the fourth. There's no other x to the fourth to combine it with. Next, I have an x. There's no other x to combine it with. The only other x is at the end here, but it's being multiplied by y. So I cannot combine an x and an xy. Got to be the same. Finally, I also have 2. There's no other whole number than this one, guys, that I can put this one with. So this problem is as simplified down as far as it can go. You cannot combine x squared and x to the fourth just because they both have x in them. They have to be the same. X squared can only go with x squared. X to the fourth can only go with x to the fourth. It's almost like, guys, and I'm sorry to be wordy on this last one, but I want to make sure you fully understand it. Think of it like sports teams. This first person, on his jersey, he had x squared. He was in a red jersey that was x squared. This next guy, he was in a blue jersey with x to the fourth. Red and blue do not match. They're not on the same team. They're in different jerseys. One was x squared, the other was x fourth. They're not on the same team. Think about them like that way. Think about what's on the same team. Like up here on number 10, both of these have an x squared. They would have been on the same team because they both have the same term. They both have the same ending with that x squared. So you've really got to focus when you're combining like terms here, all right? Guys, if you have any questions, reach out to me. Again, I can't stress that enough. I haven't heard from any of you, and I'm very upset because I really like you guys a lot, and this is where I would go on my rants in class on how you're kind of disappointing me right now because, again, I haven't heard from you. So I hope you're doing well. I hope you're enjoying your time at home with family right now. If you need anything, please reach out. Email me. If you are confused by any of this, let me know. Guys, it's been a pleasure. Have a good day.